Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about the continuation of instructions in 8051. What are the instruction types we have discussed, right? The data transfer instruction, arithmetic, logical and branching instructions. In the data transfer instruction, mainly we focused the move instructions, which is transfer between the source and destination, and how we are accessing with the memory, either RAM or ROM. In case of external memory, we are adding MOVX. In case of coded memory, we are adding the MOVC. Okay. In today's session, we will continue with the data transfer instructions along the arithmetic instructions. So, in the data transfer instruction, which is a very important instruction, which are push and pop. The push and pop instructions used in the stack pointer. Stack pointer is one of the temporary memory which is operated with the push and pop instructions with the principle of last in first out. Okay. So, which data you written in the last, that should be read as a first. So, here what they were doing, the memory is highest address is initialized. So, after doing every operations, the address will be increased, that way only the stack memory is used. Okay. So, how the data is used, if you want to write the data, then we are using the push instruction. During the push instruction, how it is performed means, first it will increase the location, then only it will write the data. Okay. So, for push instruction, first it will increase its address, then it will write. So, what will happen if suppose you are giving the push address, this is the mnemonics, right. Suppose if you are giving push 30H, push 30H if you are giving. So, here you have the location 30. So, what will happen, already some data is available on that. So, it will increase into 31 while executing the push instruction 30. Okay. So, initially it will be on the 29. Now, after that it will increase to 30, the given value will be loaded here. Suppose if you are writing the value x means it will be loaded. Again if you are giving one more data, or if you want to give a push 37 means it is not possible, because via the address only we have to give. So, only the address. Suppose if we are consecutively giving the address means first it will increase, then write, that is the principle of stack pointer by using the push operation. Now, the data is available on that given location. So, while executing the pop instruction, what it will do, first it will read the data, then it will decrease its address. Okay. Because suppose if you are writing the value of x and y, if you want to pop the data means pop y if you are giving, which will be available on the specified location. So, it will be read, then it will be reduced by 1, which is in the value of next address. If you are giving that address, its corresponding content will be read, then only store. Okay. So, you have to keep how the push and pop are operated. Push and pop will be used by the its corresponding address. During the push operation, first it will increase its location, then it will store the data. In case of pop instruction, the readily available data which is on the top layer, first it will take it, then it reduces to the next location. Then one more instruction available in the data transfer instruction is data exchange. Data exchange means it is used to exchange between the two registers. Okay. So, one of the registers should be accumulator, another will be any one of the register or memory or indirect memory. Okay. So, in case of register means how, what it will do means the D0 to D7 bits in the given register will be interchanged with the accumulator register, which is accumulator, right. If suppose I am giving the example, I want to interchange the two data 40 and 78. Okay. So, now the 40 in accumulator, now the given register R1 having the 78, I want to interchange both the values. Okay. So, for that how I am initializing means first I have to give the value. So, accumulator comma how to initialize the value by using the immediate, right. Then another data which is in R1 I have initialized as 78. Okay. So, we are using the H indicates the given number is a hexadecimal. Now, after initialization, now only I am thinking which instruction will be suitable for interchanging the both data. So, for that I am using XCH A comma R1. So, after executing this, now you can check what is the value of accumulator. Okay. So, now accumulator value and R1 value. Initially you have initialized the value accumulator as 40. Now, accumulator value was 78. Now, R1 value was 40. So, both values are interchanged, for that we are using this. Instead of 78, suppose you can have some unknown value with the location of 70. Okay. So, here you simply give it as address 70. Okay. If you are giving 70, it will understand that the content of 70 will be exchanged with the accumulator. Okay. Instead of 70, if you are using it as in the indirect register, also possible. Okay. So, these are the possibilities to interchange the data. So, now we will discuss about the arithmetic instructions. Arithmetic instruction, which is a very important one to perform all kind of arithmetic operations, right. So, the adder behind that, which will supporting for the basic arithmetic operations, mostly we are using the 4-bit adder. Okay. So, here what are the possibilities? First, what is mean by arithmetic operation means the basic addition, subtraction, multiplication and division. These 4 are we consider as arithmetic operations. Okay. Whether these 4 are possible by using 8051 means yes, we can perform the addition by using the 8051, we can perform the subtraction, we can perform the multiplication and division. Compared with the 8085, only the addition and subtraction is possible, there is no multiplication and division. Okay. So, here we have the 4 kind of operations. So, not only with the arithmetic the basic 4 operations, we can increase the registers or the content. Okay. So, either memory or register will be increased, and so these kind of instructions will be discussed on today's session. Okay. So, for these arithmetic operations, one of the condition is all kind of operations are 2 operand, right. One is a addend, another one is a agent. Okay. For subtrahend, okay, minend, okay, multiplicand or multiplier or dividend or divisor. So, we have a 2 kind of operands. So, for this, one of the operands should be loaded in accumulator, another one will be any one of the register or memory, right, or it will be you can specify it as a indirect, or you can give it as a immediate data also. So, this second data, or you can easily say the source content will be added with the destination, the result is stored in the destination. So, the format for addition is, you can give it as add destination comma source. So, what it was doing is source content is added with the destination and the result is stored in the destination. So, one of the important condition in 8051 is the destination should be the accumulator. So, you can give the format as accumulator comma source. Okay. So, this is a way. So, what it represents, the accumulator is added with the given source, the result is stored in the accumulator. These all should be a 8-bit data, because this is a 8-bit controller and the size should be same, then only it is a valid instruction, otherwise it become a invalid instruction. Now, we will check what are the possibilities of the source. So, based on the different possibilities of the source, I have listed here. So, first one is add accumulator comma, this one is a immediate data. So, any one of the number you can give it. For example, if I am giving add a comma 36H. So, what is the meaning for this means the accumulator is added with the given number 36 and the result is stored in the accumulator register. Okay. So, by this, if you know the previous value of a, then automatically the a plus 36 is added. In this instruction, second instruction is, so by this, what is the name of this addressing mode? Yes, the data is here directly given. So, it is named as immediate addressing mode. You can name it as a immediate addressing mode. The another one is the add a comma RR. What it represents? This is a register addressing mode, right? Both are registers. This RR will be any one of the register from R0 to R7. So, among this you can specify any one of the register. Suppose I taken the example add a comma R2. Okay. So, what it represents? A is added with R2 and the result is stored in the accumulator. If suppose I am asking you to add the two numbers 78 plus 29. Okay. So, what you will do? You have to do first initialize one of the data, move a comma 78h. One of the data should be in accumulator. So, I initialized 78 in accumulator. Another data you can initialize in any one. Suppose as per the example I have taken R2 with the second data. Okay. So, by this the given 2 number is initialized. The next one is we have to use the corresponding instruction add a comma R2. So, now the 78 plus 29 is added, the result is stored in the accumulator. So, if you want you can store the result. Suppose I am asking store the result at the 40th address or memory, then you can move 40 comma accumulator. So, what it represents here, there is no symbol, right. So, it is a direct addressing. So, the given instruction which is the resultant value is stored in the address. Okay. So, this is a way we are writing to add two numbers by using the register. Suppose I am asking you to what is the execution time for this instruction. Okay. So, this will consume one machine cycle, this is also one machine cycle, one machine cycle, one machine cycle. So, totally 4 machine cycles are required, right. As per the previous discussion, the clock frequency which are generated by the 8051 is divided by 12, then it will be considered as a one pulse duration, right. So, based on that you can calculate its corresponding time 4 into suppose 1.085 microseconds means. So, this kind of timing it will take to execute these 4 instructions. Okay. The another one is via the memory. So, the accumulator data is added with the address. Suppose if we are giving the instruction like add accumulator comma 40h. So, what it represents, the content of 40 is added with accumulator and the result is stored in the accumulator. It is like this kind of memory we have, right. So, this unknown data which is in the 40 is taken and it will be added with the accumulator. This is a memory access. Suppose the memory address is stored in any one of the register means you can use the last one add a comma at R0. So, both will perform the same thing, the content of the 40 only added with the accumulator. Suppose here you are the given number is 20 means the 20 plus something accumulator will perform this operation. Okay. So, these are the basic operations in addition with either immediate data or with respect to register or with the memory or indirect memory you can perform it. Okay. So, this is a simple addition. So, during the addition what will happen, what it indicates, the resultant is less than 8 bit, then okay. Suppose it exceeding its size means sometimes the overflow is occur, right. Suppose here I have taken the number is 9 plus 9, what will happen? 9 plus 9 in case of decimal we are give it as a 18, right, but here single digit I have added. Here also I am expecting it should be a single digit, but it gives us a 2 digit. Okay. So, this one is call it as a overflow or it will be considered as a carry. So, we have one of the special function register which is PSW, program status word, it is a 8 bit word. Okay. So, which will give the status of the arithmetical and logical operations. So, here if after addition if any carry is set means what it indicates, it exceeding the size. So, accumulator is a 8 bit register, it can hold the value only 8 bit. If the resultant is 9 bits, then the 9th bit is considered as a carry. Okay. So, during that time what will do, and also if suppose if we are adding the 16 bit data means there is no possibility to add the 16 bit data directly. Okay. Because the via the accumulator only we have to perform the addition. The accumulator is a 8 bit register. So, first you have to load the 8 bit, then that is lower byte to be add first, then higher byte. Okay. Suppose you want to perform the addition with the carry means the same instruction is used with the addition with the carry. Okay. The same kind of accumulated with any one of the immediate data or register content or from the memory also you can access it. So, I will give a simple example how to perform this kind of operations. So, I ask you to add the number as 72. Okay. 94 H is one number, 2 16 bit addition. The another one is 1384. Okay. Suppose this kind of number if we are taking, then how we are generally adding means 4 plus 4 is 8, then 9 plus 8 is 17. This is a hexadecimal number, right. So, here we have to do only in the hexadecimal. So, 17 means it should be converted into hexadecimal, then only we have to write it. So, 1 1. So, here I am giving the remainder value, right. This is a remainder, this is a carry. So, the carry should be take over here, right. So, now what will happen, 2 plus 3 plus 1 is 6, then 8. This is our expected answer. But how the function is performing means, during the execution of this what will happen, the accumulator result is after adding the accumulator plus the given number plus the carry flag in the program status word. Okay. In the program status word, if it is set as 1 means here it will be considered as 1 or 0. If carry is occurred, plus 1 will be performed or 0 will be occur. Okay. The same thing is repeated for the remaining registers add and indirect. Suppose I ask you to write the program for this. So, how you will write initially? You have to initialize in the value, right. I will give the simple structure. So, first I will initialize the lower bit addition. Okay. So, lower bit addition means move accumulator 94 H. Okay. Then I will do the direct addition, add accumulator comma the next data which is 84. Either you can store it in the register and call it, I will give it in the immediate addition. So, what will happen here, 94 plus 84 is performed, right. That result is stored in the accumulator. Now, suppose I want to perform the next higher byte means what will happen, again this should be via the accumulator only perform, but already we have data. So, that data will be overlapped. So, I want to move or store the data in any one of the register. So, I will store the result in the R naught. Okay. So, the lower byte resultant is stored in the R naught register. Now, I will call the higher byte accumulator comma 72, right. Then you have to use simply add accumulator comma the 13. So, what will happen here, the 72 plus 13 will be performed as 5 and 8. Okay. Then if you want to store the result at R1 comma A, the result is stored. Okay. Actually, what is your expected answer is 86. So, what about the 6 means 5, this carry. This carry how we have to include means, after adding this 9 plus 8, it exceeding the size, right. Instead of single digit it become 1 1. So, this lower one we have written, the higher one is considered as a carry. So, during this time the carry flag will be set it as 1. Okay. That is why we have to give here as add C. Add C, if we are giving, what it will do, the 72 plus 13 plus carry flag positions will be added. If carry is occurred, it will be replaced with 1, otherwise 0 plus 0 will be performed. Okay. So, during this kind of higher byte additions, that time only we have to use. Okay. In case of lower byte, no need to use the carry, only in the higher byte additions we have to use the addition with the carry. What it will represents, the carry flag is set means whenever it exceeding the size, that will be added along with this byte. So, to get the exact answer, during the 16 bit addition or 32 bit additions, for higher bytes you have to give the addition with carry. So, one more thing, suppose you are adding BCD number. Okay. So, BCD number, what it represents in the number starting from 0 to 9. Okay. If suppose you are adding the number 17 plus 12. So, after adding that the number is 9 2. So, both are less than 9. Okay. So, it is a BCD number you can consider. Suppose I am taking the another example, 58 plus 26. Okay. So, now I am adding the number 8 plus 4, 8 plus 4 is 14. So, the 14 is greater than 9, right. So, as per the BCD addition, we can't write the 14 as a resultant. So, what we have to do, this should be added with the 6, then its corresponding value only we have to write it. So, 14 plus 6 is 0, then 2. So, here 0 you have to write, here only 2. So, 2 plus 5 plus 2 is 9. Okay. So, here both numbers are less than 9. So, we can consider this is a BCD number. So, for this kind of additions, what are the facilities in 8051 microcontroller? So, now just like that you have to initialize move one of the data in accumulator. So, move a comma 58, right. Another data you can use it in any one of the registers. Suppose I am taking R1 comma 26. Okay. So, normal addition only I am using, add a comma R1. So, after this addition, what is the value is accumulator is added with R1. R1 is like before this what we have 14 remainder 1, then so 84 will be available. It is like a normal decimal addition or hexadecimal addition, but actually I want only the BCD addition, right. So, one more instruction is available in the 8051, which is decimal adjust. Decimal adjust means it will adjust into the BCD number. Whenever after performing the each addition, when the number is greater than 9, automatically it will be added with 6. Okay. So, for that each time it will be checked, then it will be corrected. Now, the resultant value in the accumulator is corrected to 90H. Initially after this instruction, the accumulator value was 84, right. Now, it become a 90. So, this is one of the facility. By using the DAA, you can automatically correct the decimal addition. The another one is subtraction. Subtraction is what it will do, one of the data should be loaded in accumulator, right. So, accumulator minus the given number or register or the source content you can say, then the resultant is stored in the accumulator. So, the source may be either immediate data, right, or registered content or address access or indirect. So, suppose I have a data from R naught, means R naught data is subtracted from the accumulator and the result is stored in the accumulator. Suppose you want to do the subtraction 78 minus 20. So, how we are writing the program means, one of the data should be loaded in the accumulator, another data either you can use it as the immediate access, right, immediate access, or you can move it into any one of the register, then you can use sub a comma R3. So, what will happen, the given register R3 value will be subtracted from accumulator, then the result is stored in the accumulator. Okay. So, this is a normal one. Suppose during the addition, suppose I am giving 20 minus 78 means what will happen. So, automatically the borrow will occur, right. So, here the negative number is occur. Suppose 28 76 16 bit subtraction, then 24 85. Okay. So, during this subtraction what we are doing is 6 minus 5 is 1, 7. So, this minus value is greater. So, I have to get the borrow, right. So, during this kind of borrow, this is a lower byte, this is a higher byte. If you are getting the borrow from the higher byte, then the carry flag will be set it as 1 in the PSW, which is program status word. Okay. So, for that what we have to do, in case of addition plus 1 we are performing, in case of subtraction we have to do the minus 1. So, for that we are using the sub with borrow instruction. So, that is sub with borrow of accumulator comma any one of the register. If suppose you are using the R3 means what it will do, the accumulator value, okay, R3 value will be subtracted from accumulator, again it will be subtracted by the carry flag. If the carry flag is 1, then 1 will be subtracted, otherwise 0. Finally, the resultant stored in the accumulator. Okay. In case of addition we are adding the carry, in case of subtraction that borrow we are get it right. So, now the 8 becomes 7, that is why we are doing the minus 1 here. Okay. So, this kind of subtractions you can perform by using this instruction. The next operation is multiplication. So, in case of multiplication, the two operands multiplier and multiplicand should be loaded in the accumulator and B register. By using this mul instructions, you can directly perform the multiplication. Suppose you have the value 30 into 15 means both are hexadecimal, then you can easily write move a comma 30 h, then move b comma 15 h. Okay. Just you use the mul a b. So, what it will do, a and b are multiplied, right, the resultant is stored in the a b itself. So, how the accumulator value is, that is the lower byte is stored in the accumulator, higher byte is loaded in the B register. The same thing is used for the division. Here the dividend should be loaded in accumulator A divided by B. Okay. So, divisor should be loaded in B register, dividend should be loaded in accumulator. After that, here we have a two kind of resultant, one is remainder, another one is a quotient. So, after performing the division, the remainder value will be loaded in the B register, the quotient value is loaded in the accumulator. Okay. So, by using this you can perform the division. In today's session, we have discussed about the arithmetic operations like addition and subtraction, how to perform the 8-bit addition. In case of 16-bit addition, during the carry is overflow is occur means, then during the higher byte additions we have to include the ADDC instruction, right. The same way, when you are getting the borrow from the higher byte, you have to use the sub with borrow instructions. Okay. So, these kind of instructions which is used to perform the arithmetic and so addition and subtraction operations, along with the multiplication and division also. For division and multiplication, the two data should be loaded in the accumulator and B. In case of addition and subtraction, you can load one of the data in accumulator, another in from either immediate data or registered data, or from the access memory access also you can use it. Okay. So, and in case of BCD addition, you have to adjust the decimal position by adding the 6 when it exceeding the 9. So, that also one of the special instruction we have DAA which will adjust. The same thing DAS also available for the decimal adjust after subtraction. After subtraction also you can use it. Okay. So, I hope you get understanding how to add 8-bit data and 16-bit data by using the 8051, right. So, the next we will discuss about the logical instructions along with the signed and unsigned additions. Thank you.